Hi children, welcome to ICT Learning. So this is the second part for chapter 3, grade 10. So if you haven't watched my previous videos for grade 10, please go to the grade 10 textbook playlist and watch all the videos from the beginning because this is the second part of chapter 3, right? Yes, we'll start this one. So this is about the number systems chapter and we were describing the first two parts, 3.1 and 3.2 in a part 1 video. So this is the second part of that chapter, right? Most and least significant positional value of a number, right? So there are, if you take a number, right, you have to get the most and the least significant positions, right? So when you consider whole numbers and decimal numbers, there's a slight difference, but if you think about whole number, right, now you have the left to right, you're reading a number, right? So if you think about the rightmost number, this place, right, is the now the digit which is in the least position is the rightmost end, right? Now think there's a number like 100, right? So if you have 0 here, 100 means the last digit is 0. So 0 will be considered as the least significant positional value. And the most significant positional value will be the leftmost value. But remember the leftmost value which is not a 0. Now think 100 is there, right? 100. If you put a 0 in front, will number change? No, it's still 100. If you put 2 zeros in front of number 1, nothing happens. The number doesn't change. That's why zeros in front of a whole number. If you're adding a lot of zeros in front to the whole number, the number doesn't change. That is why we take leftmost number, but which is not a 0. So what about the least significant number? If we have 0 here, is it adding a value? Now 100 is there. You put another 0 into the back. What will happen? It will become 1000. If you put another 0, it will become 10,000. So if you put zeros to your rightmost end, yes, it is changing the number. So that is why as the least significant positional value of a whole number, we can take zeros, right? But when you consider the most significant positional value, you have to get the leftmost number, but which is not a 0. Understood? And in decimals, the story is different because you know in a decimal number, we have the decimal point. And if you put zeros to the back or the right-hand side, what will happen? The number doesn't change. If you add more zeros to the rightmost side, number doesn't change. So 0 has no value there. And if you put zeros in front or the to the leftmost side, what will happen? Now think you have 1.1. 1.10, is it this different number? No, same thing. And what about you put a 0? 0, 1.1. Is number changing? No, still the same thing, 1.1. So if you add zeros for the leftmost or the rightmost, the number doesn't change. It's 1.01. So that is why in here we tell right extreme value, which is not 0, will become the least significant positional value, and the number which is in the leftmost extreme, which is not a 0, will become the most significant positional value. Okay, we'll do this example and see. Now this is a whole number. In a whole number, I told you, if you put a 0 here, yes, there is a value. So now anyway, there are no zeros, so you don't have to worry. So least significant number will be 9. What this means is 9 itself it's just a 9, right? 9 into 1, it's 9. So that is the least significant digit here. But 3 here, actually 3 is denoting 300s. So that is the most significant digit. That's why most MSD or most significant digit will be 3. Now this is a decimal number. Now if you forget this 0, is it a different number? No, it's the same number, right? So that's why I told you in decimals, putting a 0 after the decimal point, number doesn't change, right? So here, what is the thing? Now, least significant digit will be the most right-hand value, which is not a 0. That is why 0 is not the answer. Here it should be 7. Okay. And what about the most significant number? It should be the most, what is the most left extreme, right? So left extreme, anyway, zeros are not there. So 1 can be taken as the MSD. This is also a decimal number, but we don't have zeros. So you don't have to be worried. So a least significant number will be the most right extreme. That means 2. And 5 is the most left extreme. So that is the MSD. Now in this one, we have zeros, right? So LSD is the most right extreme, which is not a 0. So 5 is the answer. And MSD, or the most significant digit, is the left extreme. So left extreme, which is not a 0. Left extreme is 0, but not a 0 that is number 9. That is why number 9 comes. And here, again, it's a decimal number. So you have to consider about zeros, right? So here, LSD is like most right extreme, which is not a 0. So 4 will be the answer. And MSD, most left extreme number, it's not 0. It cannot include zeros, right? Then therefore it will be again 4. So 4 is the MSD and LSD. Both values are the same. Okay. So for the same method can be used not only decimal number system. So this is decimal number system. It can be used in binary, octal, hexadecimal, and other number systems as well. So we'll find the most significant digit and the least significant digit of the following numbers, right? So in the first one, it's the base 10 number, right? It belongs to the decimal number system, but this is a whole number, right? So in a whole number, having a 0 here in the rightmost is having a significant idea, right? Because if you forget this 0, the value is going to change. So always remember, in a whole number, having zeros into the rightmost is important, right? We cannot ignore that 0. So that is why in whole numbers, LSD will become 0, right? MSD should be the most left extreme number, which is not a 0. So 5 will be the answer. So this is again a decimal number system and a decimal number, right? So in a decimal number, anyway, we don't have zeros for the left and right extreme. So you don't have to worry too much. So LSD will be 1 and MSD will be again 1 because that is the most left extreme, right? In this one, we have a 0. Now I told you in the decimal number system, having a 0 or not having, it's not making any sense here, right? Because if you forget about this 0, number doesn't change. So that is why in decimal numbers, we learn the LSD will become the most right extreme number, which is not a 0, right? So it will become LSD. And for MSD, no problems, no zeros. So it will be the left most extreme. In this one, again, we don't have zeros, so you don't have to worry. So LSD will become the most right extreme number. So 9 will be the LSD. And MSD will become the most left extreme number. So that is letter A. Right? So this is a hexadecimal number. And here, again, this is a binary number which is with the base 2, and it's a decimal number, not a whole number. So in decimal numbers, we don't take zeros into consideration, right? So LSD will become most right extreme, which is not a 0. So 1 will become the answer. And for MSD, it will become most left extreme, which is not a 0. So 1 will become the MSD. I hope you understood. Okay, then there's a small thing, same concept, but for binary number system, we use this as most significant bit, right? MSB, same thing. MSD and MSB are same thing. Only thing is MSB, we use it for binary number system. So same concept, right? So here for the whole numbers, right? The right extreme value will become the least significant bit. For the whole number, zeros are considered, right? And the left extreme value, which is not a zero, will become the most significant bit for whole number. Same thing, nothing changed, right? And in binary decimals, right, we have to ignore number 0, right? So the right extreme number, right, from the decimal point, which is not 0, will become the least significant bit. And the value in the left extreme of the decimal point, which is not 0, will become the most significant bit, right? Same concept, right? Now here, MSD should be the left extreme, which is not a 0. So 1 will be the answer, right? It's actually 2 to the power 3 it's denoting, right? That means 8. This 1 is representing 8. And here it should be this LSB or LSD, same thing, least significant digit or the bit should be the any number, because it's not a decimal number, it's actually a whole number. In whole number, we just consider the right extreme number. So it's 1 anyway. So here it's a decimal number, right? Decimal binary number. So in decimal binary number, we have to ignore zeros, right? So anyway, LSB will be the right extreme number, which is 1. And MSB, most significant bit, will be any number which is which should be like the left extreme, and it should not be 0. So that will become again 1. So we'll see the activities also. Okay, so this is the most significant bit and the least significant bit activity, right? So here, this is a whole number. Whole number zeros are considered, right? So LSD will become most, the rightmost extreme number, and zeros are considered. So 0 will be LSD and MSD will become most left extreme number, which is 1, right? So this is also again a whole number, right? So in a whole number, having a 0 in front or the left extreme is not changing the number. So this 0, even though you have it or not, it's no change. So we don't consider this 0 as an important number. So here, LSD will become the most right extreme number, right? And this MSD will become most left extreme number, which is not a 0. So 1 is the answer again. This one, this is a binary number, which is a decimal number, right? In decimal numbers, having this 0 in the right hand, most right extreme or the left extreme, having zeros, we don't care, right? We only consider not 0 numbers only. So here in LSD, it should become the most right extreme number, that is 1, which is not a 0. Anyway, zeros are not there. So here it should be the MSD will become the most left extreme number, which is not a 0. So here again, MSD become 1. And the next one, here again a decimal number. So zeros into the right extreme or the left extreme, we don't care. We ignore it, right? So therefore, LSD will become most right extreme number, which is not a 0, right? 1 will be the answer. And for MSD, again, it should be the most right extreme, sorry, most left extreme number. So 1 will become the MSD. So the last one is also decimal number, which is from the base 2 binary decimal number. So in here, zeros are ignored for MSD or LSD. So in this number, least significant digit will be the most right-hand sided number, which is not a 0. So 1 will be the answer. And most significant digit will be the left extreme number, which is not a 0. So 1 again is the answer, because having these zeros, like not changing any value. Having zeros here also not changing anything. Understood? So hope you understood this exercise. Then comes the conversions, right? So now more mathematical stuffs are introduced here, right? So if you get this concept correctly into your head, you don't have anything to study in this chapter. This is like maths. So don't worry, right? We'll see. First thing, conversion of decimal numbers into other number bases. Now we have decimal numbers and we are very familiar with decimal numbers because it's from 0 to 9 digits are there. So that is very familiar for us. So now we are going to convert these decimal numbers, how to convert into different other number systems, right? We'll start with decimal to binary number systems, right? Now we have a decimal number and we are going to convert it to binary number, right? So what is the basic technique here is now you are converting it into binary numbers, right? So binary means 2. So what you have to do is you take this decimal number, right? And then you divide by 2 until the remainder is 0. Until that you continue dividing. And when you are dividing, you always have to write the remainder of the division on your right hand side. Right? So if you are learning this for the first time, yes, it will be hard for you to grab first time. But if it's kind of revision, yes, you can quickly learn this and go, right? So as I will do it from the scratch, because if anybody is new to here. So here, now in the first example, if you take 12, what I told now, this 12 is a decimal number. You are going to convert this into binary numbers. So you have to continuously divide this number 12 and you have to put the remainder. Now 12 divided by 2 is 6. Do you have anything remaining? No. 12 is even number, so it's nicely dividing by 2. So nothing is left. The remainder is 0. These remainders are very important. You have to put it. Then number 6, you again divide by 2. This is 6 is also an even number, so no remainders. And actually the answer is 3. Again 3 you divide by 2, right? This is an odd number. So you will have a remainder and the quotient or the answer is 1. 1 again you divide by 2. Now, can you divide 1 by 2? No, actually. You cannot have any value 0, but remainder is 1. Because 1 you cannot divide by 2. So there is a 1 remaining. So these remainders are very important because from this only we get the answer. Remember, when you write the answer, you should write all the remainders from bottom to top. So this 12 in decimal is actually 11002 in binary. So remember, this base is very important to be written. If you just write 1100 in your answer, you cannot get marks. You won't get marks actually, right? Because this is then it's totally different number, not a binary number itself. Did you understand? We'll do another example and see, right? So get this idea. Now 46 is a decimal number, right? We have to convert it to binary number. So when you want to continue it to a binary number, you have to divide by 2. Now 46 is an even number. You are dividing by 2. So 23, no remainders. 23 is an odd number. So when you divide by 2, the quotient is 11. That means for 23, how many 2s? 1. For 3, how many 2s? 1. It's 2 into 11 is 22. So you have a remainder. Again, 11, you divide by 2, it's 5. 5 into 2, 5 into 2 is 10. So you have a remainder 1. Then 5 is an odd number. Again, you divide by 2. 2. 2 into 2 is 4. You have 1 remaining. And 2 again divide by 2. 1. No remainders. Then 1 you divide by 2. You cannot actually divide 1 by 2. So the quotient is 0 and remainder is 1. So when you are writing the answer, you have to write the remainders from bottom to top. So 1 0 1 1 1 0, base is 2. Please write the base. Otherwise the answer is wrong. Okay, so there is an activity of 3 numbers to be converted. We'll see. This is the first number, right? We have 155 in decimal number system. So you have to convert it into binary. So I told you to convert it to binary. You divide this number by 2 and you write the remainder. So 155 divided by 2, 40 and is 77. 1 is remaining because this number is an odd number. Now how to divide this? How many 2's for 15? It's 7. 1 is remaining. For again 15, how many 2's? 7. So 1 is remaining. For this one again you have to divide by 2. How many 2's? 3, right? 3 into 2 is actually 6. So 1 is remaining. For 17, how many 2's? For 16, it's 8. So there is another one remaining. For 38, again, for 3, only 1. For 18, it's 9. So this is an even number, so no remainders. For 19, you divide by 2. 2 into 9 is 18. So that's why 9 is quotient and you have 1 as the remainder. From 9, you have to divide by 2. It's 4. 1 is remaining. 4 divided by 2. 2. 2 into 2 is 4. So no remainders here. 2 again you divide by 2. So 1 is the quotient and nothing is remaining because 2 is a even number. 1 again you have to divide by 2. So you cannot actually divide. So 0 is the quotient and 1 is remaining. So when you get 0 here, you have to stop this division, right? Then you take all the remainders and you have to write a bottom to top. So 1 0 0 1 1 0 1 1 base 2. That is the answer. Hope you got it. So next one is 472, right? This is a decimal number. You are going to convert it to a binary number. So for that, you have to continuously divide by 2. So 472 divided by 2. For 4, there is 2. For 7, it's 3. So 1 is remaining. For 12, it's 6. So nothing is remaining because this is an even number. So 2, 3, 6, you divide by 2. 1, 1. So 1 is remaining. For 16, it's 8. Again, no remainders because this is an even number. So 118. For 11, it's 5. 1 is remaining. For 18, it's 9. So as this is an again even number, no remainders. So 59, you are going to divide by 2. For 5, it's only 2. For 19, actually it's for 18, how many 2's? 9. So 1 is remaining. For 29, actually 2 into 20, 2 into 14 will become 28. So here 1 is there and for 9, it's 4. So 1 is remaining because 2 into 14 is 28. That's why this remainder is there. So 14 you divide by 2, it's 7. Nothing is remaining. 7 divided by 2, it's 3 and 1 is there. And 3 you divide again by 2. 1 is remaining and 1 has the quotient, right? So 1 again divide by 2. So nothing, you cannot divide actually. You have a 1 remainder. So after you do this division, to get the answer, you have to write the remainders bottom to top, right? So 1 1 1 0 1 1 0 0 0 with the base 2. That's the converted answer. Okay, next number is 1163. So this is a decimal number. You are going to convert it to binary. So you continuously divide by 2 and you have to write the remainders, right? So for 11, it's 5. So 1 is remaining. For 16, it's 8. And nothing is remaining. For 3 is 1, right? So there's a 1 remaining when you divide by 2. So there's a remaining 1. So here for 5, it's 2. 1 is remaining. For 18, it's 9, right? And for 1, 0, and there's a remainder. This one again you have to divide by 2. For 2, it's 1. For 9, it's 4. For 10, it's 5. So nothing is remaining. For 14, it's 7. For 5, it's 2 and 1 is remaining. For 72, you have to divide again by 2. So 3 into 2 is 6. 1 is remaining. For 12, it's 6. So nothing is there, 0. For 36, you divide by 2, it's 18. Nothing is left. For 18 divided by 9, 18 divided by 2, it's 9 and nothing is remaining. For 19 divided by 2, it's 4 and 1 is left. And 4 divided by 2, it's 2 and nothing is remaining. 2, again you divide by 2 and 1 is the answer and nothing is remaining. And 1, actually 2, if you divide by 2, a quotient is 0 and 1 is remaining. So when you write the answer, what you have to do is you have to write the remainders bottom to top. 1 0 0 1 0 0 0 1 0 1 1. Okay, so hope you got all your activities correct. So please redo these questions again and again if you don't get this concept right first time. So here we talked about how to convert a decimal number into a binary. You basically have to divide by 2 and write the remainders, right? And finally, after doing the calculation and until you get 0, you have to do the division. And after that, you have to take the remainders bottom to top. That's your answer. So now it's same thing. Now we are going to convert decimal numbers into octal. So octal means 8. So here what you have to do is you have to divide the given number. This is a decimal number. So you have to divide this number by 8 until the remainder is 0. Until the actually final quotient is 0. Okay. So this is number 158. You have to divide by 8. So first time when you divide by 8, for 15 it's 1, 78 it's 9. So 6 is remaining. 19 you divide by 8, right? For 16 it's 2. So 2 and for 16 up to 19 it's 3 remainders. So 3 is the value. 2 actually you cannot divide by 8. The quotient is 0 and 2 is left. So until you get 0 here, you have to do the division. So your answer will be, you have to always consider the remainders bottom to top, 2, 3, 6. And please write your base. It's a base 8 octal number. Yeah, we'll convert these numbers and see. So same numbers as earlier, but the answers, final answers will be different. So here it's 155 divided by 8. So 15, only 1 8 is there. And you have 75. So 75 divided by 8, it's actually 9, 72, right? The answer. So 72. So 3 is left. 3 is the remainder. So 19 again, you divide by 8. So 8 into 2 is 16. So that's why 2 is here and you have 3 left. 2 actually you cannot divide by 8. So no quotient and remainder is 2. So the answer you have to take always bottom to top 2, 3, 3. That's the answer. Next one. 472 you divide by 8. So 47, it's actually 5. 5 into 8 is 40. So you have 7 left. 72 then. 72 divided by 8 is actually 9. So it's a nicely division divided by 8. So that is why you don't have any remainders. So 59, it's actually 8 into 7. It's 56. So you have 3 as the remainder. 7 actually you cannot divide by 8. So 0 quotient and you have 7 as the remainder. So your answer, always you have to consider the remainders bottom to top. So 7, 3, 0 with the base 8. Okay, the last one for this conversion, 1163. Again, you have to divide by 8. For 11, it's 1, right? So you have 3 remaining, right? For 36, it's actually 8 into 4 is 32. That's why 4 is there, right? So how much is remaining? So 36 minus 32, it's 43. So 43, how many 8s? It's 5. 5 into 8 is 40. That is why you have 3 as the remainder. Again, you have to divide this number by 8. So for 14, it's 1 8, right? So you have 65. So 65, you have to divide by 8. 8 into 8 is 64. So that is why you have 8 here and 1 left. For 18, how many 8s? 2. 2 into 8 is actually 16, and you have a 2 as the remainder. 2 you cannot divide by 8. So quotient is 0 and the remainder is 2. So when you get the answer, you have to consider bottom to top. That means 2, 2, 1, 3. Hope you understood. Yeah, so that is the decimal numbers conversion to octal. Now we are going to convert decimal numbers to hexadecimal numbers. So for that, you have to divide the given number by 16 until your coordinate is 0, right? So 38 is given. 38 you have to divide by 16. So 16 into 2 is actually 32. So that is why you have a remainder of 2. And 2, when you divide by 16, it's actually answer is 0 and 2 is left. So this is very easy. The remainders should be written bottom to top. So that means 26 with base 16 is the equal number for this. We'll do another one and see. 47, right? Divide by 16. Actually, 16 into 2 is 32, right? So we have 15 left. And remember 15 in hexadecimal, we write it as capital F for the letter F. Okay. So 2, when you divide by 16, you cannot divide 2 by 16. So answer is 0 and remainder is 2. So you have 2 and 15. That means 2 and F. This is your answer. So they have given you some activities. We'll do that and see. Okay, first one, 256 with the base 10. So you have to divide this by 16. So when you divide 25 by 16, it's 1, right? 1 into 16 is 16. So you have left off 9. So 96, you have to take how many 6? It's 6, right? 16 into 6. So that is why you don't have any remainders. And when you divide 16 by 16, answer is 1 and you don't have any remainders. We cannot stop here, right? We have to do another steps. 1, divide by 16. So your answer will become 0 and you have 1 left. Some people stop at here, but then it's a different story. But we'll follow the same thing which is textbook is telling. So you would consider all the remainders only. So 1, 0, 0. So that is your matching answer. Next one. 478, you have to convert this decimal number into hexadecimal. So you have to divide by 16. So 47, when you divide by 16, it's 2. 2 into 16 is 32. So 32, from 47, you have to minus 32. So that is 15. So 158, there are 9 60s. And you have remainder of 40. So 29, again, you divide by 16. The answer is 1. 1 into 16 is 16. So 29 9 minus 16 is 13. So 1, you cannot stop here. You have to go another level. So 1, when you divide by 16, the answer is 0 and you have 1 as the remainder. So remember, this 14 is actually letter E and 13 is actually letter D. So here 1DE. So you can write it as capital. So this is the answer. 1DE is the answer. Okay, next number 1963. So this is a decimal number. You are going to make it as a hexadecimal number. So you have to continuously divide this number by 16. For 19, how many 16s? Only one, right? So 3 is left over. So 36, it will become 2. 2 into 16 is 32. So 4 is remaining. For 43, again, it's 32 itself. So that is 16 to 2. So remainder is 11. This number 122 you have to divide by 16. The answer is 7, right? But you have a remainder of 10. 7 you have to again divide by 16. Answer is 0 and you have left as 7. So when you write the answer, you have to write bottom to top with the remainders. So 7A is actually denoted by number 10 in hexadecimal. So this, instead of writing 10, you have to write capital A. Don't write 7, 10, 11. It's a totally different answer. 7, so for 10 you have to write A. For 11 you have to write B. And please write the base. So that is the initial conversions, right? From the decimal number, we know how to convert it to binary, how to convert it to octal, and how to convert it to hexadecimal. So from the next lesson, we'll learn more conversions. And students, I know when you learn this for the first time, it's very confusing. And when I teach the other conversions, then totally you will become overloaded with so many conversions. But there's a pattern. Right? Please study the pattern and get it to your head. Then you will know very easily. For up to now, remember, when you want to convert decimal to any number system, what you have to basically do is you have to divide with that particular base, right? And get the remainders, right? Until you have to do that until you get 0 as the coordinate. That means you cannot divide again, right? When you have to stop, right? So until that, do the division. If it's binary, divide by 2. If it's octal, divide by 8. If it's hexadecimal, divide by 16. So that's the basic thing what we learned today. So if you have still subscribed my channel, please do subscribe and please add any comments, right? If you learn things, if you don't understand something, if I want to improve something, please add those comments. So those are warmly welcomed, any comment. So thank you very much. So please watch the next part as well.